In the previous section, we saw linear search and binary search. In both these searching techniques, search time is dependent on the number of elements. Similarly, in different search trees also, the search time is totally dependent on the number of elements, and many key comparisons are performed. In this section, we'll see a technique in which less key comparisons are performed and searching can be done in almost constant time, which means that search time of an element will not depend on the total number of elements. Now suppose we have some keys that are in the range 0 to n minus 1. To store these keys and their associated records, what we can do is we can take an array of size n and store the records in this array. So a key with value I can be stored at index I of this array. For example, if the value of key is 2, then it is stored at index 2. If the value of key is 7, it will be stored at index 7, and so on. Now let's take an example of student records. Suppose each student record contains student's roll number, student's name, and student's marks. Now this roll number will be unique, so we can take this roll number of the student as a key. These roll numbers are in the range 1 to 99, so we can take an array of size 100 and store these records in this array. So this record with key 10 is stored at index 10. This record with key 97 is stored at index 97. This record with key 12 is stored at index 12. This record is stored at index 4, and so on. Now when we have to search for a student with roll number k, we can directly go to index k of this array and we can get the record. For example, if we have to access record of a student with roll number 12, we can just go to index 12 of this array and access the record. So by using this method, we can access any record in constant time, and there were no key comparisons. This method is known as direct addressing, and this array is called direct address table or direct access table. Now the clear advantage with this method is that searching is order of 1. But the problem in this method is that it can be used only when the set of possible keys is small. Now let's see why we can't use this method when the set of possible key values is large. Now suppose these student roll numbers are some 5-digit numbers instead of small numbers. So now we have these 5-digit roll numbers. Now the greatest roll number possible is 99,999. If we use this direct addressing method, then we'll need an array whose last index is this. So we need an array of size 100,000. Now out of these 100,000 locations of this array, only 100 locations would be used for storing these student records. So it's clearly lot of wastage of space. So when the set of possible key values is much more than the number of keys, this direct addressing method is not feasible. And in practice, this is generally always the case. So this direct addressing method is rarely used.